In this lesson, we're going to look at combustion reactions, specifically combustion reactions that involve compounds containing carbon and hydrogen. And we're going to look at the two different categories of combustion reactions: complete combustion and incomplete combustion. So starting with complete combustion, so this is when a hydrocarbon reacts with an excess of oxygen gas. And that's the key. That's what makes it complete combustion, is that there's an excess of oxygen gas. And when there's an excess of oxygen gas, the combustion forms carbon dioxide and water as the products. So this is the generic equation. So you've got your hydrocarbon reacting with oxygen gas to create carbon dioxide and water. So those will always be the products. So whenever you have a combustion reaction, you take whatever it is you're combusting, you add oxygen, it creates carbon dioxide and water. So you need to remember those three things, and then it just comes down to balancing the equation. So here's an example, the complete combustion of methane. So methane is CH4, so plus oxygen makes carbon dioxide and water, and it's balanced by putting a 2 in front of the oxygen and a 2 in front of the water. Compounds that contain carbon, hydrogen, and oxygen also undergo this same reaction. They still react with oxygen gas to create carbon dioxide and water. So let's look at another example. So we want to write the balanced chemical equation for the complete combustion of hexane, which is C6H14. So we start with our hexane, the thing that we want to combust. We add oxygen gas, which creates carbon dioxide and water. Then we need to balance. So we'll balance this one with a reactant product chart. So we've got carbon atoms, hydrogen atoms, and oxygen atoms. So on the reactant side, we've got 6 carbon, 14 hydrogen, 2 oxygen. On the product side, we have 1 carbon, 2 hydrogen, and 3 oxygen. So when you're balancing combustion reactions, you want to leave the oxygen for last. So we'll start by balancing the carbon. So we've got 6 on the reactant side. We need 6 on the product side. So we put a 6 in front of carbon dioxide. We now have our 6 carbons. Next, we'll balance the hydrogens. We'll just do a little update to the table with our oxygens. So now we have 13 oxygens on our product side. So now we balance the hydrogens. So we have 14 on the reactant side. So in order to have 14 on the product side, we're going to put a 7 in front of water. So we now have 14 hydrogens on both sides. Now we'll update our oxygens. So we now have 19 oxygens, 12 from the carbon dioxide and 7 from water. So when you're balancing combustion reactions, this is where you can use that method of using a fraction, right? We need 19 oxygen atoms, 19 being an odd number. So we're going to use a fraction. We're going to put in front of O2 19 over 2. So if we had 19 halves of O2, so half of O2 is just a single O, we have 19 O's. Okay, so we're balanced, but we can't leave the fraction like that, so we're going to multiply everything by 2. So that gives us our final balanced equation of 2C6H14 plus 19 oxygen creates 12 carbon dioxide and 14 water. If you are uncomfortable with the fraction issue and you get to this point where you've got an odd number of oxygens, what you can do is just put a 2 in front of your hydrocarbon and balance it again. So start again with that 2 in front of your hydrocarbon. Moving on to incomplete combustion. This occurs when there is a limited supply of oxygen. And so you're going to get products that may include the carbon dioxide and the water, but you can also get just elemental carbon or soot. So that's just C, and carbon monoxide. And carbon monoxide is the one that causes the problems. And so carbon monoxide is a colorless, odorless, highly toxic gas, which is why in homes there are carbon monoxide detectors. And the reason carbon monoxide is so toxic is that it can bind to our red blood cells and stop them from carrying oxygen around the body. So basically, carbon monoxide poisoning causes you to essentially suffocate. You can't get any oxygen to your cells. So let's look at an example, the incomplete combustion of propane. So this is one reaction for the incomplete combustion of propane. So in this case, it's creating all the possible products. But there also might be an incomplete combustion of propane. Or there might be many other combinations of products. So it's not something that you can necessarily predict what the exact products are going to be. So you will have to do some things with incomplete combustion, but it might be determining one missing product or just giving you one of those equations and asking you to balance it. Okay, but you won't have to fully predict what the products will be because they can be all sorts of different things. So we'll look at another incomplete combustion of propane as an example. So you're given a partial equation for the incomplete combustion of propane. So you know that you have propane, C3H8, and you only have 2 oxygen, and then you're going to have one product plus some amount of water. So when you're doing these kind of equations, you're basically going to start to try to balance. So we've got carbon, hydrogen, and oxygen. On the reactant side, we have 3 carbon, 8 hydrogen, 4 oxygen. And on the product side right now, we have no carbon, we have 2 hydrogen, and we have 1 oxygen. So you're going to start by balancing the hydrogen because the product that's missing is going to be one of those carbon products. So it'll be carbon, like pure carbon, carbon monoxide, carbon dioxide. There's not going to be any hydrogen. So the only hydrogen is going to go from propane into water. So we can balance the hydrogens by putting a 4 in front of that. Okay, and we know that has to stay there because that's where all the hydrogens have gone. So now we update our oxygens. So we see that they're also balanced by putting that 4 there. So the only thing that's not balanced is the carbons. So we need 3 carbons. So in this case, we can just add 3 carbons and we get this properly balanced equation. If the oxygen hadn't balanced, you may need to add carbon monoxides to add in some more oxygen. So those are the possibilities for combustion reactions. You can have complete combustion or incomplete combustion.